and indeed happy Doctor's Day. So as Dr. Naresh told, so here will be 2 days event. So first day we will be discussing mechanical ventilation thoroughly. The second day we will be discussing a few aspects of ARDS as well as ECMO. So to start, begin with the discussion, what is the principle and physiology at play during mechanical ventilation? So what is the main purpose of mechanical ventilation? Is to provide a respiratory support. What is a respiratory? What is a respiration? It is the exchange of gases between the individual and the environment. As we know, there is utilization of the oxygen and removal of the carbon dioxide. So ventilation performs few things like breathing, gaseous exchange. The gaseous exchange might happen at the alveolar level as well as at the tissue level, and finally cellular respiration. So as we are all aware of, the breathing is always aerobic. In few circumstances, like where the severe exercise or in hypoperfusion state, the breathing will be anaerobic. So in aerobic breathing, we need oxygen. So what happens is when the glucose converted into pyruvate, it enters in the Krebs cycle and it will give approximately 36 ATPs. So aerobic respiration is needed. So a brief discussion regarding oxygen cascading. What happens is, if we see the atmospheric pressure, we consider as approximately 760 millimeters of mercury, 21% is oxygen, so the partial pressure is around 160. It gradually comes down after admixture of water vapor from 150 and alveolar at approximately 100. At arterial it is approximately 100, and the venous and finally mitochondrial level approximately 40 millimeters of Hg. So before going to discuss, there is a alveolar arterial oxygen gradient to see what is the cause of hypoxia. The arterial PO2 we can obtain from the EVG, and the alveolar PO2 can be obtained for this formula. That is alveolar arterial oxygen gradient. The normal value is up to 10 millimeters of Hg. If it is more than 10 millimeters of Hg, the problem may lie in the pulmonary itself. Either patient might be having pneumonia or the patient might be having VQ mismatch. If the in hypoxic patient, so if it is normal A gradient, then cause may be extrapulmonary, probably alveolar hypoventilation. Then certain concepts regarding ventilation in general. So ventilation happens when across a tube, when there is a two different pressure points. At one point there is a higher pressure, at other point there is a lower pressure. So gas moves from higher pressure to a lower pressure so that till the pressure equalizes. Okay. So there are again two concepts. One is called as the intrapleural pressure. It is the pressure in between the parietal pleura and the visceral pleura. Usually it is a -5 millimeters of Hg. So when the inspiration, it becomes -10 millimeters of Hg. The other important pressure parameter is transpulmonary pressure. So we'll discuss these things. So various pressures and pressure gradients. So as told already, the flow of the gas to happen, there should be difference. So difference between the airway and difference between the alveolar, that is called as trans-airway pressure. If there is a difference between this pressure, then there will be gas flow. Another important pressure point is transthoracic pressure. This pressure is difference between the body surface area, pressure at the body surface area and the alveolar level. This pressure tells us about the lung expansion as well as the contraction. The another important is transpulmonary pressure. The transpulmonary pressure is the pressure difference between alveolar pressure and the pleural pressure. It is called as alveolar distending pressure. More and more when we are talking about ARDS or anything, lung protective ventilation, probably transpulmonary pressure is more important. Then coming back to the concept of lung characteristics. So we will discussing here compliance and elastance. You see there are two things here. One is called as, this is a tennis ball and one is a golf ball. So as per you, which ball is more compressible? Obviously, tennis ball is more compressible. So whenever the lungs with the minimal pressure, the volumes are more, or they can be easily distensible, then the lung called as more compliant. On contrary, golf ball, very difficult to press. very difficult to change in the sheet. So they are more elastic and less compliant. So compliance and elastance both are in inverse relation. So as told, compliance is the change in the volume per unit change in the pressure. Okay. So compliance of the respiratory system involves compliance of the lung parenchyma as well as thoracic structure. And it is by change in the volume per unit change in the pressure. So normal compliance in a spontaneously breathing patient is approximately 50 to 70 milliliters per centimeter of water. In intubated patient, approximately 100 millimeters of water. Then coming to static compliance. The static compliance is important because the compliance of the respiratory system when there is no gas flow. So that is called as static compliance. So how will you calculate during a mechanical ventilator? It is by expiratory tidal volume divided by plateau pressure minus peak pressure. So it will correspond to pleural pressure, plateau pressure. So all these pressure and equation will be dealing in further lectures as well as in the workstation also. So the resistance, during the flow, the resistance what is offered by the respiratory system as well as the airway and the endotracheal tube we have to consider. So the trans airway pressure is a pressure difference between the mouth as well as the alveolus. It is given by the formula difference between the peak pressure divided by plateau pressure minus divided by flow. So if flow is, you see, commonly we keep a flow of 60 liter per minute. So the difference between peak pressure and the plateau pressure will approximately give the airway resistance, that is trans airway resistance. There is one concept called as time constant. The time constant is a product of compliance and the resistance. So the time constant is a terminology when we use the amount of time required to inflate as well as deflate the lung units. So what happens is, there are two scenarios where like COPD versus in the ARDS. Where the ARDS, the compliance of the respiratory system is significantly dropped. So the time constant is significantly less. So that these patients we can ventilate with a higher respiratory rate. So up to 35 cycles per minute. Why? Because the time taken to inflate and deflate the lung alveolar volume is very small. On contrary, when the ventilating patient with the COPD, the time constant is compliance is significantly high. So that the time required for the alveolar to empty is significantly high. There we cannot ventilate with a higher respiratory rate. So we have to have a low respiratory rate. There the concept of time constant comes. Then what are the ventilators? This is negative pressure ventilator. Have you anybody seen negative pressure ventilator? It is now not in use. It is commonly used in European countries in polio epidemic. This is negative pressure ventilation is nothing but our mimic of spontaneous breathing only. It is used, you see, the complete body is enclosed in the iron carcass. This is called as iron lung also. Okay. So the negative pressure is applied, which is transmitted to the intrapleural pressure and patient breathes. So nowadays this not used. Probably this iron lung, which is last used in 1990s. So to have a just discussion, we will have put this. So now coming back to the positive pressure ventilation. The positive pressure ventilation, here again there is a pressure difference between at the upper airway and the alveolus. So when the ventilator emission breaks, so there is a positive pressure, and here is the either 1 or 0 atmospheric pressure. So there is a air movement, gas movement from upper airway to the alveolus. Till that point, both pressure equalizes. Then ventilator stops giving up breath. Okay, so then the alveolar pressure becomes more than the airway pressure. With the help of lung elastic, expiration will happen. This is the all basic basic principle of mechanical ventilator. So again, coming down to the airway pressures, there are two things. One is called as resistive pressure and one is called as elastic pressure. The resistive pressure, it is pressure required to overcome the resistance of airway and the endotracheal tube. This is called as resistive pressure. So this is given by the formula. It is flow into resistance. The other is elastic component of the pressure. Elastic component is the pressure required to distend our lung tissue as well as chest wall. So it is given by the formula of volume into elastance. But as we know, elastance is inverse of compliance. So volume into the 1 divided by compliance. So overall total, what is the trans airway pressure become? It is a flow into resistance plus volume into elastance or 1 by compliance. So where is the utilization or the will happen? So these are the inflating pressures. Okay, when initially breath happens, it will inflate till the peak inspiratory pressure. That is the work required to overcome the endotracheal tube and airway resistance. So this is called a resistive work. So elastic work, the work required to overcome the elastic properties of lung and the chest wall. This is called as elastic work. So how the application is, suppose if your resistive work is increasing, but the after inspiratory hold, plateau pressure are the same, where will the pathology lies? That is airway level. So either you might be having tube kinking, you might be having excessive secretion, or you might be dealing with the either COPD asthma condition. The next is the elastic work is increasing. So, but if the elastic work is increased, the peak pressure is also going to increase. Now, so where the problem lies, there is a decrease in the compliance. So, what are the causes of decrease in the compliance? Same as mentioned, patient might be having ARDS, patient might be having pneumonia, or patient might be having pneumothorax. The main thing is that it is a parenchymal problem. So if the work in the elastic work is increasing, that is the main thing is a parenchymal problem, compliance related problem. If the resistive work is increasing, it is at the level of airway, or there is a tube blockage or kinking of the tube, or you might be dealing with the COPD or asthma, airway related diseases. Then coming back to one of the important concept, mechanical breath. So mechanical breath is usually controlled by three variables, that is called as trigger, what is called as limit, and is called as cycling. So if you divide any mechanical breath, this usually has a three component. So what is meant by trigger? Anybody? Yes, the trigger is what initiates the breath. So it is called as trigger. Again, the trigger has two. It is either ventilator trigger or it is a patient trigger. So when the ventilator trigger, so the ventilator gives a breath after certain period of time. Suppose if we keep a respiratory rate of 12 per minute, so the total cycle will be up to 5 seconds. Okay, 60 divided by 12. Or if you keep at 50, that 60 divided by 50 is 4. So after every 4 or 5 seconds, the ventilator will give a breath. That is called as time trigger, ventilator trigger. So coming back to other trigger, patient trigger, it is either flow trigger or the pressure trigger. Then how flow trigger works? So there is a bias flow in the circuit, so which is constantly there. Either it could be 5 liter per minute or it could be 6 liter per minute. This bias flow will be running from the inspiratory end of the circuit to the expiratory end. So whenever the patient breathes, so there is a deflection of certain volume. So suppose if we keep a flow, bias flow of approximately 5 liter, there is a patient breath, and if we keep a trigger sensitivity of 3 liter, so the 3 liter will be deflected. So this 2 liter will be sensed by the ventilator, and the ventilator giving the breath. That is called as flow trigger. So wherever there is a flow trigger, if you want to keep a flow trigger more sensitive, you can reduce this. So out of 5, only 4 will be going, and only 4 will be detected by the circuit, and 1 is more sensitive flow trigger. You understood the concept? So flow trigger, what happens is, ventilator circuit has a basic flow. Okay, either it could be 6 liter, it could be 5 liter, that is continuously circulating between inspiratory limb and expiratory limb. Okay, so what happens is, whenever patient tries to take a breath, there will be deflection of the flow, and reduced flow will be coming back to the expiratory limb. So that will be detected by the ventilator, and ventilator will give the breath. So if you want to make a trigger, a flow trigger more sensitive, okay, so you can reduce the sensitivity to 2 liter or 1 liter. Then what will happen? Instead of 5, so almost 4 liter will be coming to the expiratory limb. Only 1 liter will be towards the pressure. The minimal effort, 1 liter will be minimal effort. So maximum flow will be towards going to the expiratory limb. The ventilator will give the breath. The advantage is of what? The work done by the patient is minimum. So overall the work will be reduced. So nowadays everybody with a ventilator will prefer flow trigger. Coming back to the pressure trigger. So as we know, if there is a drop in the pressure, if the patient tries to breathe, so then ventilator will give another breath. That is called as pressure trigger. Then this is another shape signal triggering. is very uncommon, not very common use. It is only thing is that when the expected expiratory waveform is different from what is recorded in the ventilator will give the breath. So not necessary to remember. For these all the 2-3 trigger points what we have discussed, that are enough. This is only for theoretical purpose, for discussion purpose. Now limit variables. Limit means what are the factor is limited by the ventilator or the controlled by the ventilator. This is volume limited, means at any point of time volume will be constant. Okay. So here you see the pressure graph, pressure times usually it is like elliptical portion, but the flow will be always constant. Usually it is a square waveform. Your ventilator has also decelerating flow pattern. So the pressure may rise, okay, in the volume control ventilation. Why? Because the compliance is worsening. So the ventilator will give the fixed volume. Pressure may go up. There is no control on the pressure. So how will you define the volume control breath in the control mechanical ventilation? It is a time trigger, flow limited, and the volume cycle. Okay, understood? Now next is pressure limited. Pressure limited means the pressures are not going high beyond a certain point, but volume is not controlled here. So you see all the pressure graph usually the uniform. Okay, so the flow time and the volume will be delivered will be variable. That depend upon the compliance of the respiratory system. So how will you define the then pressure control ventilation? So if it is control ventilation, it is again time trigger, pressure limited, and time cycled. Understood? So this is volume control, where the both control ventilation, time triggering. Okay, something you are controlling here. Here volume and flow are one and the same. So whenever we are putting a flow volume control ventilation, automatically flow will also be controlled. So it is a flow limited, and whenever the volume is delivered, ventilator goes from inspiration to expiration. That is what is volume cycling. That cycling happens. So in pressure targeted or pressure control ventilation, again control ventilation, time is the trigger, pressure will be controlled or pressure will be limited, and time cycle. After that particular period of time, the ventilator goes from inspiration to expiration. Now this is coming to spontaneous breathing. There is pressure support ventilation. Here what happens is patient will be the trigger. Patient will trigger the breath. Then the other is flow is cycled. The inspiration to expiration will depend upon the flow. The flow we can set. So here, suppose if we keep a flow 25% of the peak inspiratory flow, if the ventilator reaches till 25%, the ventilator will go in the cycling. So again pressure limited. Here the only factor is pressure is governed by the ventilator. Rest all parameters are governed by the patients. Except that flow will be, if the flow is reaching for 25%, depending upon what we keep. You can keep 25%, you can keep 40%. So the ventilator goes from inspiration, cycling happens from inspiration to expiration. Okay. So then what is the SIMV? It is a synchronized intermittent mandatory ventilation. Okay. So this is also one of the weaning model. Not very commonly used, but what happens is when the concept behind is when the patient is getting better, so why not to keep a certain mandatory breaths and certain breaths which a patient can take. So certain mandatory breaths are supported by the ventilator, okay, and certain breaths patient can take. So but the problem is that the work of breathing will be more high. The certain breaths are not supported, so patient will feel fatigue. So here, whenever there is some trigger is happening in the mandatory breath, the ventilator will coincide and give a mandatory breath. So usually SIV is added with the pressure support. So certain mandatory breaths and certain which are the spontaneous breath which are supported by the pressure support. So this is one of the mode of weaning. But they found that with this the work of breathing usually is going to increase, but not very commonly used. Still some people use the SIV. So what is the difference between the control mode and assisted mode? That is assist control mode, sir. Anybody? So let be an interactive session so that will be. So what will happen is control mode, every breath is controlled by ventilator. Here assist control mode, patient will be initiating and all the breaths are assisted by ventilators. It is nowadays there is a concept of control mode is like decreasing. Whenever the patient is not taking any spontaneous breath or patient is paralyzed, then the ventilator will be acting as a controlled mechanical ventilator. But nowadays all the patient ventilator have assisted control. Any breath is triggered by the patient will be completely supported by the ventilator with its parameter. Either you keep at volume targeted assisted, or you can keep as a pressure targeted assisted. Okay. Now the next concept of I ratio. What is I ratio? It is a ratio of inspiration to expiration. What is the normal I ratio? It is 1:2. Once one part is inspiration, two parts is expiration, or 1 second will be inspiration happening, 2 seconds will be expiration happening. So in certain condition, we'll keep it as an inverse ratio. In which condition we'll keep it as an inverse ratio ventilation? So ARDS or hypoxemic respiratory failure. But what will happen? Why we'll keep like this? So whatever the pressures and all, we want to give over a period of time. So if we keep inspiration 1 second, so the expiration also 1 second, that is called as inverse ratio. So both will be equal, so that over a period of time the inspiration is given, so the more alveoli we can participate or more alveolar recruitment happens. So this is to improve the oxygenation. But the drawback is there will be consistently increasing, excessive increase in the intrathoracic pressure. So if the intrathoracic pressure will increase, there will be hemodynamic instability. Next, what will happen is, if you see expiratory time you are shortening, definitely there will be CO2 retention. Next, what will happen? Autopy. Okay, so if you are decreasing the expiratory time or you are inversing the ventilation, these things may happen. Coming back to like decreasing the I ratio. So for COPD or obstructive airway disease, what we keep expiratory time more prolonged, so that washout of the carbon dioxide will happen. So all these hemodynamic changes you can, what is previously seen, may not happen here. CO2 will be like easier to wash out the CO2. Autopeep also will not be there. Okay, but the problem of that, what we are getting benefit previously of alveolar recruitment will not be there. Coming back to another entity that is called as pressure and volume loops. Okay, so here we'll target a pressure, and y vertical axis there will be the volume. So this is the control breath. What happens is, you see the inspiration is happening, then the expiration. This is the anticlockwise. Spontaneous breath, this is the reverse happen. So you lot of information also you can get. You see here, this is a control breath. How much PEEP is attached here? There is absolutely, if it is beginning from here, there will be no PEEP. Okay, and here is a negative deflection, it is coming. So it is a assisted breath. The patient is triggering, rest is controlled by the ventilator. So here again the inspiration and the expiration. So the this is the elastic work and this is the resistive work. Okay, so what is happening here? Over-distillation of alveoli. How will you see? So you see, if you ventilate beyond this point, there will be no increase in the tidal volume, but there will be increase in the pressure. So you are over distending the alveolus. So what you have to do? Just reduce the volumes. Okay. Again, then what is happening here? So you see the pressures are dropping, pressures are less, and more our tidal volume is there. So what will happen? The compliance is better of this. The system which you are ventilating usually have a better compliance. Usually in emphysematous patient. What is happening here? Given pressure, there is a drop in the tidal volume. So compliance has dropping. Either you are dealing with either patient will be having ARDS or the patient will be having congestive heart failure. What is this information? What is this ventilator? So you see, this is what, how you see this is volume targeted. So you see, whatever the pressures are increasing, this volume will be the same. Okay, this is the pressure volume loop in volume control ventilation. So the compliance is dropping, pressure volumes are same, but the pressures are increasing. Okay, this is how you see in the poor compliance. so that volume will be delivered, but the pressure may increase. Same thing in pressure targeted, pressure control ventilation. Volume may decrease, but the pressure will remain same. These are the information given by the pressure volume loops. So what is happening here? The expiration is not touching. There could be circuit leak. You have to find out from where the circuit leaking, or there may be some misconnection, or you have ETC source port that has disconnected. So there is some leakage happening. Okay, cup might be ruptured, or there is this small hole in the ventilator. So this you have to inspect from patient end to the ventilator end. So again now flow volume loops. This is one of the important entity will give an information. Mechanical ventilated breath, inspiration is usually always positive and expiration will happen. Okay. So again here y-axis we have flow and the x-axis we have volume. So what is happening? If the expiration has multiple serration, you can think of any secretions or water in the circuit and all. You have to do just suction. So again there is it is not, flow is not returning to the baseline. There will be auto peep or might be air trapping may happen. So you can increase the flow, decrease the respiratory rate. These methods use the bronchodilator and all. So this air trapping may also see in this flow time graphics. So these all will be further discussed in station, and don't need to worry. You can do interact one-to-one during the workstation also. So again there is a scooped out expiratory graph. Usually in COPD patient or patient is having airway increased airway resistance. Just give a bronchodilator therapy. So coming to the final point, take home message of this class will be, so physiology we have to remember of the ventilator and all, how the respiratory mechanics works. There will be flow happens between the difference between two pressure points. We have to have all these scalar and graph give a lot of information. Always look for the what are the pressures, what are the volumes, how much delivered. Many times what happens is, though there is no physiological benefit, the ARDS ventilating with the pressure control mode, we put on pressure control mode so that the better oxygenation. But forget to check the volumes. As the compliance worsens over the time, the volumes will go on dropping and dropping. Similarly with the volume control ventilation, the pressure may go, we may ignore the pressure. So always look for the what are the scalars telling, what are the loops are telling, what are the ventilator alarms are telling. Okay. So these are only, and also patient ventilator interaction. Not only see the ventilator, how the patient is also. Many times what happens, there is increased work of breathing evident. You have all the respiratory muscles scaling, and that will show that there is increased work of breathing. You have to see also that. So nowadays, like always, we try lung protective ventilator strategy. We keep always a plateau pressure less than 30. We try open lung ventilation with adequate speed. That will be further discussed. The plateau pressure, driving pressure. The driving pressure is a relatively newer concept. So that will be again further discussed in next few lectures. Thank you. Any doubts?